In this blog, I want to talk about the stern gear of the boat. I've already posted a short post about selection of the motor and a rather lengthy post, I admit to being a bit verbose, a rather lengthy post about selection of the propeller. So here is the Tema 132 15 kilowatt PMAC motor, and here is the 18-inch diameter, 14-inch pitch canal line propeller from Michigan Marine. So the question today is, how do we get power from the motor to the propeller? And like all things in Perseverance, I didn't just follow the standard way of doing things. There are a few novelties along the way. So the first thing we need to deal with is how to support the propeller. And that obviously is done with a propeller drive shaft, but the drive shaft has to sit in a bearing. Now, conventional oil grease bearings exude grease into the cut, and we are depositing grease into the canals as each boat goes along. Also, you need to remember to lubricate these things, and my memory is getting progressively worse, so I don't want to have to do routine actions. The answer therefore was to fit a water lubricated cutlass bearing, and the first step is to show you how that works. So here we have another couple of components of the stern gear. The propeller drive shaft is a straightforward circular shaft with a taper on the end to fit the propeller. And here is the cutlass bearing I spoke about. Cutlass bearings are interesting because they are water lubricated, so water from the canal flows up inside this, and as the shaft rotates in these 8 grooves, water films are established on each of the flat surfaces, and it's the high pressure of a film of water being squeezed between the steel drive shaft and the rubber of the bearing that gives a pressure to hold the shaft in place. It's actually quite a loose fit, so I'll put this on the end of the shaft like this, and you can see it's actually got a little bit of wobble to it. That's not the tight mechanical fit that you're used to with other bearings. When this is in the right place, water will actually flow up inside this tube, and so this is going to be inside the water. The next thing we need is a stern tube to hold this to the boat. So let me fit my pretend stern tube. The boat, this is the swim. You've got water on your side of the boat. I'm sitting in the dry, and the propeller is of course in the water. I'll remove the side of the boat. And this plastic tube represents the stern tube. I don't have the actual stern tube here, it's welded into Perseverance already, but this shows you the length of the stern tube and how the cutlass bearing sits in that tube. The water is free to travel up the cutlass bearing and fills the tube with canal water. So at some point we have to stop the canal water coming into the boat, and for that we fit a seal at this point in the shaft. Now we've already established that I hate doing routine maintenance, so it's possible to fit maintenance-free seals, and I'll show you that next. These are the two parts of the maintenance-free seal. They seal by having a very smooth stainless steel surface rubbing against a very smooth, flat carbon surface. And those two simply rub together and form a watertight seal. Okay. This part fits on the shaft, and this will clamp onto the stern tube on the boat. And as I said, water is coming up the stern tube and will come out of this gap. This part will slide over the propeller shaft until it mates with this face. At that point, there'll be a water seal at that point. Now I'm not going to assemble this because the O-ring seals on here have to form a watertight seal on the shaft, and the more times that you assemble it and disassemble it, the more risk there is of damage to the seals. But that's where the water will stop coming into the boat, and all you have to do in order to establish that film of water is squeeze these bellows fractionally, and then the rubber bellows hold a small pressure against that to keep the two faces together. So here's our partially completed stern gear. We have the propeller drive shaft, the propeller on the end, the cutlass bearing that is supporting the shaft and allowing it to rotate with a film of water, a stern tube that's full of water welded into the swim of the boat, and a seal to stop the water coming into the boat. So if we rotate this shaft, the propeller will push water backwards and push the boat forwards. It means there's enough force in this shaft to push the boat through the water. We can connect this shaft to the motor and allow the motor mounts to push the boat forwards, but that means to say that the motor mounts have to both support the motor and accept the forward force to push the boat through the water. To my mind, it's better to separate the two tasks. And so for this reason, in Perseverance, we have a thrust bearing. And here it is. The thrust bearing sits on the shaft between the propeller and the motor. In the hull of Perseverance, there is a thrust plate, which is a steel plate welded into the swim of the boat. And this thrust bearing transmits the forward thrust from the propeller into the structure of the boat. It's supported with these rubber mountings, and there is a clamp that fits into this slot around here to clamp the thrust bearing onto the propeller drive shaft. By doing this, we separate out the forward thrust from the rotational force in the shaft, and now all we have to do between the motor and the propeller drive shaft is transmit torque. So we need a coupling. Okay, we're getting close to a complete system now. I've raised the motor onto its mounting brackets. These are conventional adjusters, and then soft rubber anti-vibration mounts. They only have to take the weight of the motor and account for the torque of the motor when it's pushing the propeller round. These wooden brackets are simply to represent the structure in the boat. When it's on its proper mountings and the propeller drive shaft is in the right place, these two shafts will be very close to being in alignment. You can never do things perfectly, so we need a coupling in between these two which can accommodate a little bit of lateral, vertical or angular misalignment, and which can transmit the torque from the motor to the propeller. This is one half of the coupling. I've got the other half here, which I thought I'd show you. It's got a series of teeth around the outside and the inside of this part. And so when this mounts on this propeller drive shaft, there'll be two of these facing each other. And the torque from the motor is transmitted to the propeller through this rubber donut. It's an elastomeric component that will transmit torque from one to the other, but accepts some degree of distortion. I'll assemble this so that you can see what it looks like. So here it is, the finished stern gear for Perseverance. The propeller mounted on the propeller drive shaft, the cutlass bearing to support it, the water seal to keep the water where it should be and not in the boat, a thrust bearing to take the thrust from the propeller and leave us with zero thrust into the motor so that we can use an elastomeric soft coupling at this point. The motor is mounted on conventional elastomeric anti-vibration mounts. Well, thank you very much for persevering to the end of this video. I hope you found it interesting, and I look forward to meeting you around the system one day, and I can show you this installed in the boat. Thank you.